So now have a look. Draw and find the common tangents. Now something they will ask you, identifying the common tangent.
Suppose
Identify.
circles. They're asking a question. It was like, so there's two circles here. They're asked
Mhm.
like point of tangency is easy for them because you can just go like this and this. But for the other things, it's like hard, the radius and stuff.
Okay, so see, we can draw common tangents or like see, have a look. We can have, let's suppose we have two circles and they are intersecting in this way. So these are the 2 points of intersection. You can see the point number A and point number B. Or
Mm.
the circle can be like this, that they will intersect just at one point. For example, this is my circle and
Yeah,
I'm trying to draw a circle in this way, like they will intersect at just one point. Here you
mm.
can see, right? Or
Yeah.
do we have other options to make it? Yes, of course we do have. A
Mm.
circle I can draw like this, and we can have a circle like this.
Usually they have like a space between them.
Yes, just intersecting with, or we can have a circle like this. We don't have any intersecting points.
Yeah.
So we have a see, first approach, that we don't have any intersection between the circle. Second, we can have one intersection here. So this is known as the tangent circles.
Mm.
This is known as the tangent circles because this is just passes through the intersecting at the single point. So this kind of like only one point of intersection is there. That's why it is known as the tangent circles. Tangent circles. Only one point of intersection. Okay, it's not the circle again. It's just a point of intersection. This is also, you can see here, this is just only one point of intersection here.
Okay.
So this is also known as the tangent circles. There's a no point of
But
intersection. No point of intersection.
no point of
Tell me.
intersection. So that
And
one can have tangents that connects them in this way.
sorry.
So that the no point of intersection one will have tangents that go like this around the water.
Like you want to make the tangent in this form, in this way.
No, the one that has no point of intersection.
Okay, so we don't have, see, if you will draw a tangent, so this is not the common tangent.
Yeah, don't worry, that will go like this.
Okay, you want to join like this.
Yeah, that's how it will go, right?
So yeah, of course we can draw a tangent like this, but this is not like we will say it's going to be see, I'm just trying to show here like it's my two circle having no intersection point. Yes,
Okay.
but of course you can make a tangent that will touch two the circles in this way. That's not the issue.
Then how will we make a common tangent for that one? We just have to make one.
Common tangent. So see, let's suppose I have a circle again. I'm taking a tangent. Let's take a one more. Or you can take in this way also. Two circles intersecting each other at single point. So common tangent is there. That's sharing
Yeah.
the tangent with both the circles. Similarly, in this example, you can see this one is also the example of the same thing. Two circles having the common tangent.
Hmm.
Okay. So here also two circles we have having the common tangent,
Hmm.
right? So that's
Yeah.
also, and here they are not intersecting to each other.
Okay.
And one, like we can have the two intersecting point also. Here you can see. So the circle can have no intersecting point, two circle can have one intersecting point, and two circles can have two intersecting points, right? So if they will ask you how many intersecting points can be there, so that answer will be 0, 1, and 2, right? Clear?
Yeah.
Okay. So the question will be draw the common tangents. For this one, of course, the very first one, let's suppose I have a circle in this way. This is the point, and another circle that's going to be my like this in single row. Yes. And we need to draw a common tangent. Common tangent. Similarly, I can have try to draw the common tangent, please, and show me.
For those two, there are the levels. Um, for these two, I think the common tangent will be like this, right? This one.
Yes, we can we draw more number of tangents?
Yeah, you can draw one at the top and at the side. Not the
Yes.
side.
Try this.
You can draw one at the top and bottom.
So yes, That's going to be my, we can draw, see, there are, let's take 2 points here. So that will be like this.
Yeah.
Or 2 points here, 1 and 1, 2. Yes, in this way. And please make arrow. But see, we have like this. If I'll take a point here and a point here, see, if I'll draw like this, so it's also going to be my tangent, right?
Yeah.
Yeah, perfect. So again, I'll get 1 point here and 1 point here. So that will give you a tangent like this also. So how many tangents we got? I think I
Yeah.
got 4 tangents,
Just
right?
add it like that also.
Yes, that's, see, we tangent means just it should intersect at single point to the circle. It doesn't
Okay.
matter what's the direction. If you will see, this is the common tangent that is sharing with the, that touches the two circles at.
So if they touch each other, if the circle, the tangent touches the circle in some way, shape, or form, there'll be common tangent.
Yes,
Okay.
it should be touches just at one point. It should not be like this. It should not be like this. Have a look. It should not be like
Yeah, because
this.
that's going through. That's a core or seesaw.
Yes,
Whatever.
of course, of course. Come on. So four, I got 4 tangents here.
Mm.
Can we have more options? Of course, I don't think so. And now for the second part. This is my A, let's suppose this is B. For the B one, I can have a tangent. How many tangents will be there?
That'll be
Two I
two.
can see. Two I can see clearly.
The third one can be like coming right between them.
Yes. And third can be my, that will pass through the center, right?
Yeah.
Like this. Please don't forget to draw the arrows. I got 3 tangents here.
Yeah.
The last one.
That'll only be two tangents, right?
Two. Yes. Perfect. So it's going to be my have the 2 tangents only.
Okay.
One.
What if the circle is inside the circle?
See, if I have kind of this one, this
Yeah.
is not the concentric circles.
Mm.
Concentric circles. Circle. So here, see, you can either make the tangent of the inner one or the outer one. You will not get any common tangents here.
Yeah. That's it.
So this is my concentric circles. Or see, concentric circles are, or we have the circle that are not intersecting. These are the examples of the no point of intersection. No point of intersection. Okay. As we have done here, see, we have seen how many like intersecting points that can have. So we have no point of intersection means 0 point of intersection. So that's example, concentric circle can be example of no point of intersection also, right? And 1 point of intersection, we can have two types of examples. You can see this diagram and this diagram is my 1 point of intersection example. And this is my 2 point of intersection example. Clear?
Mm.
If they will ask you to draw the circles that will intersect at just 1 point, please make sure that you will make both the diagrams, not just one. Okay, we have two options. Can you see?
Yeah. Only if it's at the end, though, not if it's in the middle.
Yes. See, just make sure like how many options. See, if we can draw two in two ways. Either this one circle and is inside and touching at just single point, or both the circles are outside but touches at single point. This can be two options. Yes.
Okay.
So next, what we have?
We have to do finding arc measures.
How many common tangents that we can have that they will ask you. So see, you can. How many common tangent to circle that can draw them, state whether the tangents are external tangents or internal. You know about the internal and external tangents, right?
So what?
See, have a look. This is something we have.
I mean, this is all they taught me. Sort of. There's going to be more of a test than this one.
So can we draw our tangents? Circle can have this one. Yes, that's all the common examples we have already discussed. This is the same thing. They've asked like this is the circle. Can we draw a common tangent?
No.
No, right? So they have asked. So and one example is kind of this one. Can we draw tangents?
Yeah. We draw
Yes,
one.
right. Yes, we can have. And similarly, how many tangents that we can draw for this one?
We can draw two.
So how many tangents will be there?
Two.
Uh, 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 the last one.
Sorry. Four.
Oh,
No,
right.
no, wait. One, two, three,
Outside.
four.
Yes. That can be of like
Now we
this. And two kind of this one that we can be treated as outside. And this one I
draw
can treat inside, right? So if I'll take it as 2 points, so it will be treated as inside, but there's no
Hmm.
meaning of any inside discussion. But see, this is going to be my outside.
Hmm.
Oh, only one array. You know what's the how is my handwriting. Okay.
Yeah.
Now tangents is done using the proper tangent. Now property of the tangents. Have a look. Some properties of the tangents. Properties of tangents. So see the tangent at the point of contact, at the point of tangency. Let's suppose I have a tangent.
Property of
So
tangent.
from the center, if they see, if I'll draw a radius to the tangents. This is my tangent point, right?
Yeah.
So that will make our 90 degree over here. So tangents line to circle theorem. So this is theorem number one. Theorem number one, which is known as the tangent line. Tangent line to circle theorem. Circle theorem, the very first one. So that is my P is the, let's suppose, point of contact. So in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at the end point of the circle. That means theorem number one states that tangent line and to circle theorem means the line will be my tangent line if and only if it will make a 90 degree with the radius.
If only from 90 degree.
Correct.
Mm-hmm.
So this radius R is perpendicular to, let's suppose this is my point A, B. So this is my tangent B. So R is radius which is perpendicular to A, B line, which is my tangent.
Okay.
So it states that if the line AB will be perpendicular to the radius, then only we can say that AB is my tangent. Clear? So if I'll tell let this RM.
Okay. This M.
So
Where did
this
M come from?
R radius is perpendicular to Q. Yes, that's we have done.
What this part again? This one. What is
Can
that?
I? Sorry.
What does this mean? The line and the line under it. I forgot.
Okay, okay. This means perpendicular.
That is.
Perpendicular means 90 degree. So O to P, that is my line segment OP, that is radius, should be perpendicular to AB. Clear?
Okay.
And
O
one more
to
thing is
P.
there.
Wait. So the theorem is that they have to be perpendicular to each other, right?
The theorem states that if I write down the statement, so line, this AB will be my tangent if and only if this O to P, that is radius, will be perpendicular to it.
Okay.
Okay, otherwise it's not will be your tangent, right? So in short, if the definition according to the tangent line to circle theorem states that a line segment, a line segment is a tangent, is tangent. You can say a line segment a tangent if and only if and only if the line is sorry, a line segment, not line segment, on line, only line, sorry. A line is tangent if and only if the line is if the line is perpendicular to the radius, to a radius, to a radius, to a radius of circle at its end point of the circle. or
What's
the
the point
intersecting
of the
point,
circle?
endpoints of circle.
What is
Endpoints.
what is its endpoint?
Endpoint means the from O to P. P is my endpoint here, right?
It's just at the end of the circle.
Is there's the point of contact you can say. So of the circle at point of contact you can add point of contact. Add
Point tangent.
point of contact.
Yeah.
Will that be fine?
Okay.
Great. Now external tangent congruence theorem. So this is my first theorem. Second theorem is, I hope it's clear to you, right?
Yeah.
So this AB tangent is perpendicular to the radius R, or we can say the O to P, which is my radius, of course. O to P, which is my radius, is perpendicular to AB line. AB is my tangent. Next theorem number 2, that is very important. That states that external tangent congruence theorem. Congruence theorem. That means if I have a circle and I have an external point, let's suppose S. What do you think from this given external point, how many tangents I can draw?
Infinite. Like for the circle, right?
Sorry.
For the circle, you can draw infinite.
Yes, this is my point, external point. I need to draw
Oh,
tangent segments on this circle. So how many possible options will be there?
on the circle or in the point outside? Why is the point outside?
Tangent will be on the circle itself, right?
Yeah, but why is the S outside?
So if I ask you like how many tangents I can draw from this point, specifically this point. So I can take one tangent like this,
Oh, okay. Got
and
it.
one more option will be there. I can draw one tangent like this.
Yeah, two.
So I think we have only two options. If I'll try to make a tangent here, so this is not going to be tangent because this will extend and this will intersect at 2 points, right?
Mm, that would be the
It's secant it will become. So this is not going to be our option. So only we can make two tangents. How many tangents? Two tangents. Getting my points?
yeah.
Yes. And this is not a tangent segment from here to S. Let's suppose this is my R and this is T. So I have just fixed this. From R to S, I have fixed this. This is my tangent because it's touching at the one point. But since it's a fixed length, it's a fixed length, therefore I'll say that it's my segment.
Okay.
So this is my tangent segment. Tangent segments. Clear?
Yeah.
Yes. As we know that line segment is something that is fixed value. Similarly, it's my tangent segment. Why I'm using the segment word here?
The segment was because it's like it's in it's an area and you can shade it and it will be like
No. See, that segment is different. That's circle, and inside the segment that was different. That was different. Like line segment was there, and code, and this that was
uh,
different. Here I am like relating this segment word with the line segment.
okay.
Line segment is a small part of the line that is having the fixed endpoints.
Okay.
Okay, and then we have a ray having one fixed point, but one point is there that we can extend infinitely.
Mm.
And then we have a line only. Line states that we don't have any fixed point. We have the extension on
That
both
is
the.
line segment. These
That's
are
a
line
line,
segments.
right? So what I
Yeah.
have done,
So
I've just removed this line. I have used the word tangent here.
yeah, that's what
Tangent
I
segment.
said.
Tangent
It's
segment means,
segment.
although tangent means there is a line, right?
Yeah.
Tangent means a line, but tangent
Yeah.
segment means a line segment, just a smaller segment. So that means
Mm.
from R to S is my tangent line, tangent segment here. This is my tangent
Okay.
segment.
Mm.
Okay.
Okay.
And by this theorem, this length and this length both will be same.
Okay.
That means RS is equals to T and S. That's the important theorem. Please keep in mind. So if I'll draw tangents from an external point, so I'll get two tangents and both the tangents will have equal length.
Okay.
Clear? So from external point, we can draw two tangents. How many tangents? Two tangents, and both the tangents will of same length. Getting my point?
Okay.
So tangent segments from a common external point, segments from a common external points, external
Mm.
points, external point, external point are congruent. Congruent means equal length, right?
Yeah.
means equal length. Please keep in mind. Important here.
Okay.
Now they can ask you to, are you taking a note? So how many tangents that we can make from a single exterior point?
How many tangents you can make from a single?
Exterior points or external points?
Two.
Two
Around.
tangents.
Yeah.
Yes. So stomach, only two tangents.
Yeah.
Only two tangents can be made from an external point. External point. Okay. Only 2 points. Only two tangents. It's only two tangents I can. Only two tangents. Two tangents can be made from an external point. And that two tangents will be same in length.
Okay. Okay.
Hmm?
Hmm.
Okay, so that's all. One more thing is there, just to verify. Verify our tangent.
Okay.
So it's a tangent or not, we need to verify. This is my circle and this is center. Our point T is there. So we need to verify that it's going to be my circle. This is my tangent or not. T and S. This TS is my tangent or not. TS is tangent. This is the question mark. TS is tangent or not? Tell me.
TS is that an S of I? Oh, yeah, that's an S. TS is not tangent,
Why?
right? It is an external point.
See TS. TS means this is my
Yeah.
this
I
is
thought
length,
that
right?
was a 5.
Why it can't be your tangent?
I thought it was a 5.
Okay, okay. So it's going. Okay, this is my five, and this is my S.
Hmm.
Okay. So tell me, can TS be a tangent?
Yeah.
So
Okay.
always keep in mind, you will not say yes just by looking at the. If there will be a measurements given 3, 4, and 5, so you will have
Yeah.
to check whether it's follow the Pythagoras theorem or not. Do you know Pythagoras, right?
Yeah.
Pythagoras means what? Hypotenuse square.
A square, A square
Yes,
plus
base
B
square
square is
plus perpendicular square. So what's the hypotenuse should be here? See, we know that
equal.
the tangent makes 90 degree with the radius. Yes.
Yeah.
Yes. So this is going to be my 90 degree. This should
This
be
is
my 90.
90.
Getting my point?
Yeah.
So this is my S, this is my T, and this is my P. So this is going to be 90 degrees. So P and S is my hypotenuse here. This is 4 and this is my 3. So PS is 5. 5 square should be equals to 3 square plus 4 square. Check 25, 9, 16. 25 is equals to 25. So yes,
Minus
true.
16 minus.
So it's true. We can say yes, T and S is a tangent. Clear?
Yeah. Yeah.
Yes.
That's how we check if it's congruent or not.
Uh, why
Well, not
congruent?
congruent, sorry. Like, it has
Yeah.
to be equal to each other.
Yes, yes, yes. So that's now another question is there. Like suppose again we have our same term, but this time the measurement given is, let's take 2. This is my 4. This is the 3. This is 2. So will that be my tangent T and S?
T and S, 3, 2, 4. So, 3 is hypotenuse. So, 3 square equals,
Not 3 is not the hypotenuse. This should be,
right?
see this
Oh,
this
it's
here
upside
it's
down.
90 degree.
That's 4 is hypotenuse.
The longest one. Yes, longest one will be my hypotenuse, right?
Yeah.
So hypotenuse square, that's going to be my perpendicular square plus base square.
Okay. Perpendicular square times B. So, 4 square equals, is perpendicular square or is it base square? It doesn't matter
See, you
what all.
can take any number as a perpendicular, just hypotenuse, check which is the hypotenuse.
Hmm.
Hypotenuse is important here. So the longest one is the hypotenuse.
Wow. As long as so
You
4
can
plus
take any number as a perpendicular, any number as a base. That's not the issue.
This is not tangent because
That's perfect. This is 4 square. B is my anything. 3 square plus 2 square. 4 square is 16, but here is 9 and plus 4. So 13 is equals to 16, which is not true. False. That means we can say, therefore, we can say TS is not
tangent.
a tangent. So see, if measurements will be given and it looks like it's a tangent, but you will not declare it as a tangent once it will not follow the Pythagoras theorem. Getting my point, Mridini?
Yes.
Okay, if this is going to be my circle and this is TS given. So now again the same thing. Will this TS be your tangent?
Yes, it can be.
Yes.
It can be.
The answer will be yes. There will should not be any doubt in mind, like whether it's going to be Pythagoras theorem or not, because no measurement is given, right?
Yeah.
If no measurement is given, that we don't need to think about the Pythagoras theorem. We need to just check the it is intersecting at single point or not.
Okay.
Clear? If there will be 3 measurements given, then it must be they want to know that you know the concept of 90-degree or not.
Okay.
Okay. So please for the TS, it is going to be your tangent. But if this kind of structure will be given, 3 numbers will be given. So please find out whether it's 90-degree or not by the help of the Pythagoras theorem.
Okay.
Okay. So that's all, Midni, for today's session. Okay. So I hope it will help you to prepare for the quiz. And when do you have the quiz? Thursday.
So Thursday or Friday.
Okay, okay, maybe. So we will finish this one, of course, up till the next session. I think there's a few concepts just still pending. So we'll discuss in the next session, right?
Okay.
Okay, thank you. Thank you so much, Midni.